Okay, welcome back to A1 Success. Yesterday, I alerted some topics under physics, which is confirmed that we're going to come out because some of the questions, some of the topic, I check it right from 2006 up to date. The topic like elasticity, electricity, and projectile normally come out. That is why I shoot a video under projectile yesterday. But I will not be able to take everything. It's not possible to take what you have 3 years to do and I treat it here. It is not possible. That is why after this one teaching today, you go back to what the topic and read it by yourself, and you go back to the previous video I sent. And today I'm going to talk about the elasticity. This is the topic, elasticity. Then let me talk about the elasticity before I talk about the mathematical aspect. The ability of material, the ability of material to regain its original position, original size, or original shape after being distorted or being stretched is called elasticity. Again, the ability of a material to remain its original position or original shape after being distorted or being stretched is called elasticity. Look at the spring. When you stretch a spring, it will come back to the original position. When you press it, it will come back to the original position. Likewise, look at the football. When you stretch the football or you compress it, it will return to the original position. This such material is called elastic. So it's said to be elastic, which means elastic are the material that can fall under this particular definition. Any material that can be distorted or being compressed or being stretched and come back to the original state is called elastic. It's called elastic material. Now, what are the things that we are going to talk about? Such particular thing. We talk about first thing, elastic limit. Elastic limit. And we call yield points. So let me quickly talk about these two particular terminology. Elastic limit simply means when you stretch a particular string, before reaching the plastic form, is called elastic limit. That is, by the time you stretch a particular material, before reaching the maximum weight you put to that particular material, before reaching the plastic form is the point at which the elastic limit has been destroyed. So it's called elastic limit. So yield point is the point where a particular material transform to elastic limit. That is, it will not gain the original shape back. For instance, if you stretch a string, a point you will reach where by the time you leave that string, it will not come back to the original shape. Such say is called yield point. So I hope that one is clear to you. Now let me now talk about some. Then we have under this, we have Hooke's law. It's a scientist that illuminates elastic material. We call such particular Hooke's law. So Hooke's, but it has Hooke's law. So this Hooke's law is formed under elasticity. It talk about the elastic material. Then how did Hooke's law come about the law? It says when a spring is attached at one end and a force is applied to the other end, the extension of the spring is proportional to the force applied to it, provided the force is not large enough to extend the spring permanently. What it means is that look at the spring now. When you place a mass here, the spring will extend. When you place more mass, the string will extend. So he now said, that is what he said, when this spring is attached at one end and a force is applied to the other end, the extension of the spring is proportional. It is equivalent to the force applied to it, provided the force is not large. Meaning that the law is still exists unless the force is large enough to destroy this elastic material. That is law is talking about. You can also say in this form that the extension is proportional to the force applied to it, provided the force is not large enough. You can also say in this simple form that the extension is proportional to the force applied to it, provided the force is not large enough to destroy the elastic limit of that particular material. These are the two ways. Now, according to the what? Hooke's law. Let me now say this law. According to Hooke's law, what I'm saying is this. Hooke's law is what? Force is proportional to the extension. I want to derive the formula. See, the force is proportional to the extension because Hooke's law says that when a force is applied, when the spring is attached at one end and a force is applied to the other end, the extension is proportional to the force, which means this is force that is proportional to the extension. Now, this is proportionality. Before it can become an equation, there must be what? Constant of proportionality. And what that is constant is called F is equal to KE, where our K is equal to constant, which is called stiffness. We call it stiffness or force constant. Either you call it stiffness or force constant. Now, what is the unit of K? K is now equal to F over E, which means the unit of force is equal to Newton and the extension is meter, meaning that the unit is equal to meter per and Newton per meter, or you rather say Newton meter per 1, which you can write the unit of K to be this. Now, let's now apply it. I'm going somewhere. Let's apply let me quickly apply. Let me form one question. They can just think the formula cannot be more than this I'm telling you now. Now, look at this one. Let's say this question and write the formula. Let's say this one. Now, let's say a spring. So follow us, of natural length 3 meters. That is the natural length. Is extended by 0.01 meter by a force of 4 Newton. What will be its length? Its length when the applied force is 12 Newton. Now, what are we looking for? Is the what? What will be the length when the force? We want to look at the length. Now, this means that a spring of natural length of the spring, which is L0, is equal to 3 meters. L0. So it's extended by this. So extension, which is E, extension is equal to 0.01 meter. Meaning that when you have a spring, this is a spring now, it stops here. So when you now apply a force, it now extends to this, which is extension is 0.01. So we now have to wonder that, okay, this is what the force we apply to is what 3. Okay. So this is by this force is extended to this. They want to know by this 12, what will you do? What the length by this 12. So now we now apply the force. Force is equal to KE. So the force of this, the force that applied to get this one is what? Is equal to 4 Newton. So we want to know the force of 12, the length when the force is now 12 Newton. Now, number one, we want to find the what? The force constant, which is the stiffness. So meaning that our force is equal to 4, then our K is unknown times extension 0.01. Meaning that K equal to 4 divided by 0.01. What will be the K? So I don't want to I want to avoid any form of error here. So now 4 divided by 0.01, we have 400 Newton per meter. That is the force constant. That is what I can find here. So now in this case, we still have to use the same equation. So we now say if now force is equal to K here at the same time. So this is force. We want to know the extension when this one is equal to B. So the force is now 12. Now say 12 equal to K times E. Now we know our K to be this 400, which is equal to 400 times E, which is the extension. That is when you apply this 12 Newton. How will this particular material extend? So the length. So it will now be equal to, make E the subject of formula. E will now be equal to 12 divided by 400. So 12 divided by 400, what is our that? So it will now be equal to 12 divided by 400. So we have 0.03. Meaning that at 4 Newton, the material extends to 0.1. Then at 12 Newton, the material will extend to 0.03 Newton. Okay, this is, you have to say meter. Now, to now know the extension, you know, they said, look at they said, what will be the length what will be the length of that particular so the length must have been extended to this, meaning that to say it now because of force, it now be length will now be called L naught, which means original plus what? E. E is the extension. So we need that extension is this. So original length is equal to 3. So it now be L is equal to 3 plus 0.03. Meaning that the length of the material will now be 3.03 meter. So this is our final answer. I hope I broke it to your own level. So that is the answer for that. So let me give you, before I move to another question, because I still have one question to show. So this is our final answer here. Apply this. Just try to manipulate it. So I hope you can grab this before I clean it. So now, let's now move to. Now, I need to say something here again, which I need to say before I talk about. There's something called, it's not here, but I will say, there's something called the tensile stress and tensile strain. Tensile stress and tensile strain. Stress and tensile strain. Now, I will not talk too much. You are the one. I will write it in mathematical form so that you. So, tensile strain is equal to force over area. Why the tensile stress? Tensile stress is equal to extension over original length. That is definition. So, if they ask you, find the tensile stress, I did not prepare what I just want to give you a formula because of time. Because I'm still going to take another topic after this. Tensile stress is equal to force. If they say the force of so over area, just define it. So the unit will now be force over area meter square because area is measuring. So or the stressing strain. Let me write this formula. Strain. So it's equal to extension over original length. Now it has no formula because meter all over meter cancel. So it's right. It just have numerical value. It has no formula. So I mean it has no unit. So I believe that one is clear to you. So I'm not going to work. I didn't prepare any question there. Just know that this is the formula because of time. So now, then the second one that we try to say here is after this one. After this one, we are moving to another one. You like? Okay, I will still talk about that one. There's something called Young modulus, but I will still go to that later. Now, look at this question again. Let's see how we can work on this one. Let's look at this. Let me clean this one first before we now write another question. It's under that one again. They now say, and look at this one. I want you to think about this. An elastic wire extends by 1.0 centimeter when a load of 20 grams hang from it. So when a load of this 20 grams handle is extended by about this. So they now ask you that that is the first question, what additional load will be required to cause a further extension of 2.0 centimeter. So now the question said that an elastic wire extends by 0.1 with this load of 20, when it's just load of 20 grams hang from it. So what the additional load will be required to cause extension of this? That is, that will cause extension of another extension of this, further extension of this. We require to cause a further, to extend further. That is, to extend from 0.1 further again to another one. What it requires. Now, the first thing you do here is very simple. What we do is this. Number one, we say it's still the same. That is why you have to acclimatize with this formula. The force is equal to KE. Know that one first. Now, if you look at it, this is force, and this one is gram. If you look at this one very well, it's gram. They are demanding for what? Then, what is force? Force is equal to weight, which is equal to mass times acceleration due to gravity. So, meaning that we convert this one. And remember that it is not in kilogram, it is in gram. You need to convert it from gram to kilogram, meaning that we divide this by 1,000. Meaning that to have this one now, we say 20 divided by 1,000. To convert it to kilogram, open bracket again. Now, this one, you will have to say force is equal to mg. G is 10, so multiply by 10. So you have converted this one to what? This one to force now, because initially it was in what? Mass. You want to acclimatize with this formula. Then we now say K times this extension. Now, this one demand of the conversion of scale, because they are asking, because inside this one, they want to test of your scale, how to convert scale, how to apply the formula. So, meaning that this one is equal to what? 1 divided by 100. Why? Because 100 centimeter make 1 meter. So, we convert this one to meter. So, this one will now be equal to, this one cancel this. You have 20 divided by 100, then equal to K times 0.01. Now, this one divided by this, let me use calculator. I don't want to make any foolish error. So, because then divided by, I know, but let me just use calculator direct. So, this one will now be 0.2 equal to 0.01 K. Make K the subject to formula. K will now be equal to 0.2 divided by 0.01. So, we now have divided by 0.01. We have 20 Newton per meter. Now, let me tell you one thing. One of the basic things is a numerical value and the what? The unit. So, this is the numerical value and the unit. You must not put it, otherwise, any failure to put unit is what? Is minus half. So, remember, minus half you are getting. So, now, the next thing is this. They now say, we have gotten the word K. They now say, what is the additional load that you needed? Which means you need to add it to force. So, meaning that the same thing, you see, say, F is equal to KE. Now, in this case, we now put this one, open bracket. This one is force. So, convert this one to weight. We have to say, we say the mass is equal to, okay, 0. Divide this to what? Mass. So, this one converted. So, 20 divided by 1,000. We have 0.02. This is a mass now. And the force is equal to times 10. We convert this one to star. So, open bracket, additional weight, let it be M. Call it M. Because they say, what is additional load? That load is mass. Now, times 10. Since the force is equal to mg. So, mass is this. This additional mass, you want to make the subject of formula. This 10, g is equal to 10. So, now equate it that. What is the stiffness or force constant? The force constant is this. So, K is equal to what? K is equal to 20 times. Then additional load. Let me get. This is what? It has extended to what? From year to year is 1.3 centimeter. So, they want another additional to what? To 2 centimeter to here. Meaning that what is the total extension? The total extension is equal to 3 centimeter. I think you are getting it. So meaning that the total extension, because they say further, they didn't say what is the what extension to 2. They say further after 2 points. So further again. So meaning that 3. So meaning that we put 3 here times 3 over 100. Now, why is it 100? It is in centimeter, and 100 centimeter make 1 meter. We convert it. So meaning that we have 0.02 plus m, then times 10 outside equal to 20 times 0.03. That is it. So now what we do is this: multiply by this, we have, and open the bracket. 10 times this will give you 0.2. Then 10 times we have plus 10m equal to, then this time it will give you 0.6. Now collect right hand. So we have 10m equal to 0.6 minus 0.2. So we have 10m equal to 0.4. 0.4. Just like 4 minus 2. So divide both sides by 10. So m is equal to 0.04 kilogram. So this is additional weight. If you put this weight here, it will extend to particular, it will give another addition of 2.2. So that is that on that. So now, I will even say this one. This is what I did not prepare for, but I will put it here. So try to write this one. I hope it's clear. It is, you can see this one, how I work it from here to get this one, substitute this to this, because you make m, you always say, when you are working, you say let m be additional weight, which I did not put here. You say let m be additional weight. So now let's leave this one. Let's now move to this. Another one that I need to tell you is there's something called young modulus under the terminology of this. So we call it young modulus. So there's something called young modulus. I don't need to define it more. So I don't need to define this one more. What I need to do is to write the equation. So the equation of young modulus is equal to tensile stress all over tensile strain. So that is what I can say under young modulus. Young modulus is equal to what? Is the ratio of tensile stress over tensile strain. You can write it mathematically equal to this. So we mean that young modulus is equal to tensile stress all over tensile strain. Now, if you look at this one very well, we can call this one equation star. Let's call this one equation star. In case you are not giving the direct formula, they can try to make it in a integral form. What I mean, in a part form, so that they gave you some parameter, but they didn't give you this one direct, stress and strain. They didn't give you direct. So you remember that I said the tensile stress is equal to force over area. So call this one equation star. So now, and the tensile strain is equal to extension over original length. So call this one equation star. Now, if you look at this, substitute all this into equation star. So we can say E. Some textbooks use E for tensile young modulus. So this young modulus will now be equal to force over area, then all over E naught. So L naught, F over A, then over E over L naught. So we just put this one together to form this one. So now we can call this one equation star. Now, if you look at this one critically, they may ask you to make it in another form. So tensile stress can also be what? Can also be in form of what? F over A, then you divide this one, meaning cross multiply, times L naught over E. Now, you remember that this is L naught is called the pressure, because the pressure is the force acting normally per unit area. That is the definition of pressure. Pressure is the force acting normally per unit area. We can also say the pressure times L naught over E. So this is another formula which can be equal to equation dagger. This can be equation dagger for another formula. So in case you are asked to make F the subject of formula, in case they gave you force and young modulus and other parameter, you are asked to find the force. So you make this force the subject of formula. We can say F and E over 1 cross multiply F and L naught over AE. So cross multiply, we now have FL naught then equal to FE AE. Then what we use to make F the subject of formula, divide both sides by L naught. So this one cancels this. So therefore we have F equal to E, which is equal to Young modulus times area, then E all over L naught. So call this one equation dagger star. Dagger star. So this one can also be useful for this. Now, if they ask you what is the unit of another one, what is the unit of the Young modulus, you can see. Now, you know I said strain is extension over original length, so no unit. So definitely the unit will still remain what? The unit of stress, which is equal to Newton per meter square. So it's all, you write it like Newton meter minus 2 power. So you can write it. So I believe that that one is clear. Now, after this one, you can replay this one because I want to quickly clean it because of time. So if you want to check it on the YouTube channel, you can pause it or you download. Better for you to download. You can even do it when you get to 100 level. You can store it and start study about it. So the next thing that I will talk about is work done in an elastic material. Work done in an elastic material. Work done in an elastic material. Now you know that from the mechanism, we say work is said to be done when the point of application of force is moved. Now, what I'm saying in essence is this: when you stretch a spring, it will extend, which means what you apply it to extend is force. You put force. So definitely anything that force resort to what? Extension or to movement, is the work has to be done. Meaning that in this case, from the mechanism, we say work done is equal to force times area. Times distance. All this one equation star. All this one equation star. Now, because we want to relate it to normal elastic material, this blend, which is called distance, will be extension. We call that one extension. So that work done will now be equal to force times E instead of load. So this is also extension. All this one equation star, equation dagger star. Now, in this case, if you look at this one physically, you can say, when you extend the spring like this, definitely it will start from 0 to what? To certain force. So now, as a result of that, the average work done will give you average force equal to what? 0 plus F all over 2, then times extension. So meaning that work done equal to half Fe. So call this one equation dagger. All this one equation dagger. So now remember that this F equal to KE. This F equal to KE from the Hooke's law. So transform, let's call this one equation dagger star. So put this one into this. So now say work done equal to half times open bracket KE, because this one is already KE, then times E outside. You give us half KE squared. So call this one equation dagger. So call this one equation dagger. So this is the formula to calculate the work done in an elastic material. So after this one, let me showcase one particular question in which we are going to apply this particular thing. So as I'm saying, you can download. The best thing is to download into your application, so or your phone or your Android. Continue any gadget, continue watching it. Make it as one of your reading source. So study source. So now let me try to write this equation. One of the questions here. Now, if we will now say if the spring has a stiffness, I told you that either elastic constant or stiffness, but here they use stiffness of 950 Newton per meter, then I say what work will be done in extending the spring the spring by 6 millimeter. So we want to know, if you see this question, what will born in your mind is two equations. The other we say work done is equal to half Fe. Then we have another formula. Work done is equal to half Ke squared. These are the two things you have. Now, if you look at the question very well, which means a stiffness have this, you have the stiffness, K is equal to this, so you don't need force. In some cases, they will give you force direct. You not say what is the work done, so you don't need force. So what you need is this. You are looking for work done. That's half equal to 1/2 times the what the stiffness, which is K. K is the stiffness. Remember, it's constant, which is equal to 950. Then times extension, open bracket, because we need to put square. Now, if you look at this one, they didn't put it in what? A meter. They say millimeter, which means 1,000 millimeter make 1 millimeter. So 1,000 millimeter make 1 meter. Sorry. So meaning you have to divide this one by 1,000. You square it. Now we will still need calculator. So we now have equal to this times 950 times then 3600 36 then all over 1 million. This will be 1 million. Yes, it's 1 million. So definitely this one cancel this. This one cancel this. This one cancel this. So we now have this one cancel this. This one will be what? 118. So we now have work done equal to 95 times 18 for here. 2 divided by this 18. Then all over 1000. So let's multiply it. So we have 95 times 18 will give us 1710 divided by 1000. 123, which will be 1.71 joule. So this is our answer for this particular question. Welcome back to A1 Success. So now this is electricity. I'm going to talk about electricity now. Now, before I talk about, let me tell you the definition of electricity. The study of charge, either in motion or at rest, is called electricity. That is definition. The study of charge, either at motion or at rest, either in motion or at rest, is called electricity. Meaning that we have two types of electricity. Then, if you can grab my definition, the study of charge, either in motion or at rest, is called electricity. So, meaning that electricity can be divided into current electricity. Then we also have static electricity. So these are the two types of electricity. Now, the study of electricity in motion is called current electricity, while the study of electricity at rest is called static electricity. I want you to understand that one. Now, what is now current? Current is the rate at which the charge flowing. So current is the rate at which that charge is flowing, or charge per unit time. So meaning that current, which is denoted by I, equal to Q over T. Now from here now, we can say what is now charge. The charge can be equal to what? Q is equal to IT. Call this one equation 1. So this is the formula. So I'm not going to give you all this one, it's elementary. So if they ask you the time and current and time, so the charge is this. That is the formula. Now, in this case, we need to talk about something, parameter, which I've illustrated here. Now, before I move to this, let me talk about EMF and potential difference. The EMF and PD. This PD means the potential difference, while EMF means electromotive force. Now, let me start with electromotive force first. Electromotive force is the is the what is the total work done in taking a unit charge round the circuit in an open circle. The total work done, which is measured in what? Volts. The total work done in taking a unit charge round the circle in coulomb, or we can say the work done in an open circle. Now, what I mean is this: if you look at this battery, if you check it, it is 1.1 volt, which is EMF, not PD. It is not potential difference. So this is the total. We have not connected this one at all. This is open circle. So when you now connect any load like battery to power it, definitely it will not reach 1.5. It will reach something like, instead of 1.5, it can reach 1.2, which means it has decreased, which is called PD. Is that taken? So meaning that what is potential difference? Potential is different is the energy, is the work done in taking a unit charge from one point of this terminal to the another, which means you have connected to this terminal, negative and positive, to another point in a closed circle, because you have closed it. Why do you close it? You have make it to what? To power something. So it is now PD. So both these are measured in what? In volts. So now, then what is the unit? What is the instrument used to measure potential difference and electromotive force? The instrument is called voltmeter, which is denoted as this symbol. Is denoted as this voltmeter. And what is the instrument used to measure the current? Current is what? Denoted by this. It's called ammeter. And the current is measured in ampere. So I want to short it like this. So now, let me see another thing I need to tell you before I move to another. So we have let me talk about the symbol. Symbol in an electrical circuit. This is what we call cell, which is a unit of battery. The cell is a unit of battery. Then when we now say this one combined with this one, this is a positive and negative. This one combined with this one, like that. This is no longer a single unit. Meaning that this is a battery, and how do we define battery? A battery is the combination of two or more cells. When you connect two more cells together, it becomes battery. That is why they call this one battery, because it contains combination of two or more cells to make battery. So now, then what is another electrical symbol? Another electrical symbol is this. This one is called key. We call this one key. Then we call this one transformer, and this one is called inductor. So all this one can come out in your circle. So this is what transformer, and this is what inductor. Then we have another formula, another symbol. This symbol is called resistor, or you can write it like this. You can do it like this. This is also resistor. But when you play this one here like this, it becomes variable resistor. This is the standard resistor before this one. It's a standard, but when you put this out, it becomes the variable resistor. So let me stop here for the electrical symbol. Go and check more because of time. So now, in this case, let me now go back to, before I now talk about this, let's talk about the word resistance. Now, if you look at your tap, you can control the amount of water flowing in your tap. This is just like resistor, or you stop it, that will not come at all, that the water will not come. That is what resistor does. But the phenomenon, the process is called resistance, meaning that resistance is the ability of a conductor to resist the flow of electric current. The ability of a conductor to resist the flow of electric current is called resistance. That is why different wires has its own internal resistance. Like that is why people normally demand for copper wire. Copper wire will conduct electricity more than aluminum wire because it has low internal resistance. Is that taken? Now, what is now resistor? Resistor is the device that resists the flow of electric current. It is not process. It's a device. That device that resists the flow of electric current is called resistor. I did not bring that. I can show you what is resistor. So now it's a device. So now, before I talk about this, let us now talk about Ohm's law. Ohm's law. Now, when I ask you what is Ohm's law, now it's a man, it's a scientist that first illuminated the relationship between the voltage and current. He now stated this law. Ohm's law states that the current passes through a metallic conductor. The current passes through a metallic conductor is directly proportional to the amount of potential difference passed through its end, provided the temperature and other parameters remain constant. Again, Ohm's law states that the current passing through a metallic conductor is directly proportional to the amount of potential difference passed through its end, provided the temperature or other parameters remain constant. So, what it means is this. It means that as the higher the what, the higher the current, the higher the voltage, the higher the current. The lower the voltage, the lower the current. That is direct proportional. So as a result of that, we are going somewhere. So meaning that if you now have to prove it, you now say, since Ohm's law says that voltage is directly proportional to the current, there, last time I told you that before it can become equation, there must be constant, and which means that we now say voltage is directly proportional to IR, where R is equal to constant, which is called resistance of a material, resistance of the material. So now this is the resistance of the material. So now then, because different material has its own resistance, ability to resist the flow of electric current. So I want you to this one, you download it on the YouTube channel. So we have gotten that V is equal to 1 this. Now for this one, equation 1. Now let's now go back to the former resistance. We say the ability of a conductor to resist the flow of electric current is called resistance. Is that okay? So it can also be defined from this equation. Then R is equal to V all over I. Call this one equation 2. So they can allow you that say what is resistance? You say resistance is the ratio of potential difference per current. They can accept the definition if you can do it like this mathematically. You define it like, because when I do mark it, I discover that we accept it, that we should define it like this. The ratio of potential difference per unit current, it can also be acceptable. That is another definition of resistance. So now, after that one, I've done this. So let's now say, in a case of where we have something, I want to prove another equation. I prove two equations now. Now, let's now say the EMF, the current along the EMF. Now, you know that V is equal to IR, whereas we have I equal to V over R, where this is called external resistance. In case we have our battery that have what? Internal resistance. There is internal resistance in this battery. So definitely we now make this one, instead of say EMF is equal to this I, open bracket. Instead of R, we have R plus that internal resistance. Call this equation star. And this is equation star. Let's start from here. Now we can modify this one. We can say I equal to E over R plus R. Equation star. What I mean, you divide both sides by R plus I, R plus R small r, to get this one, which is this one can be equal to E. Now I believe that one is clear to you. Now from here, we can say from here that I V over R equal to E over R plus R. So we can say equation star. This is I, this is I. We can equate it together, if you remember that very well. So now, after this one, take note of this equation. Now let me clean it, because we are still going to apply this one. Now, before that, let's now talk about the resistance. Okay, let me talk cell in series and parallel. Cell in series and parallel. Let's talk about if a cell is in what? In a series, we have what? We have this one plus this one plus this one, like that. So the equivalent or effective EMF is equal to E1 plus E2 plus E3, like that. Your addition. But if the cell is in parallel is this. We have so now if you look at this one very well, now what I will tell you is this: all the cell, we have only one cell. If this one is 5, which means what we read in the EMF is just like a 5 volts, but this one addition of volts. Now let me now tell you definition. A cell is said to be connected in series when their corresponding ends are joined together. A cell is said, if they ask you the definition, a cell is said to be connected in series when their corresponding ends are joined together, meaning that this end joined to this one, if you connect it like this. But if you connect it like this, it's side by side, then it's equal to what? In parallel. That is, the wire here you connect to this, the wire here you connect to. But if you connect it together like this, it's said to be in series. So now, a cell is said to be connected in parallel when the cell connected side by side and their corresponding ends are joined together side by side like this. So now, let me now talk about the cell in what? Series and parallel connection. Now, series resistor, let me say resistor in series and parallel. We are not talking about resistor now in series and parallel. Now, the same definition. A cell is said to be connected in series when their corresponding ends are joined together. Now, if this one, like this is a resistor here, this one joined to this one joined to this one joined to this, is that taken? So it's said to be in series when their corresponding ends are joined together. And we have the voltage here connected to this voltage. R1, R2, R3, and R4. Now, you can ask to prove that the what? Y R equal to R1 plus R2 plus R3, like that. Now, what you do is this. You can see this one now. Let me put it to 3. Now, if the current is flowing, the same current will flow to this, the same current will flow to this, and the same current will also flow to this. Is that taken? But they have different potential difference. You are not with me. They have different potential difference. Why? Because I times this depend on the resistor. It will make it to be lesser. I times this like that. So meaning that from Ohm's law we have V is equal to IR. Meaning that we say the voltage here V1, the voltage here V2, the voltage here V3. Now it will now be equal to, then voltage will have, total voltage will now be equal to V equal to V1 plus V2 plus V3. That is the total voltage that supplied to this. Now you remember that V is equal to IR, meaning that this one will be IR. For this one, we have what? This is what? IR1. This is what? IR2. This is what? IR3. So addition. Now, if you look at this, what is common here? I is common here. I is also common here. It cannot be IR equal to I bracket R1 plus R2 plus R3. So this I cancel this I. So therefore, our R will now be equal to R1 plus R2 plus R3. Proved. So this is how you prove this one. You can see. Now I will apply it one question offhand. So now you can download it because I can't wait because of time. So now, and it is measured in ohms. So the value of resistance. So let's now prove for the one in parallel. Yes, in parallel. You can see side by side. This one connect to this, this one connect, this one connect, this one connect to this, this one connect to this. Now we have a terminal which is called voltage here. Now we can see. Now let me tell you this now. Now if the current is flowing here, when it gets to each junction, just like water is flowing, we have three taps. So one will flow here, another one will flow here, another one will flow here. Let's call this one R1, R2, then R3. So now meaning that they have different current. Current will divide here. Current 1, current 2, current 3. Now, if you look at this one very well, the same voltage passes through. The same voltage, unlike the first one, different voltage but the same current. But here, the current here has been divided into 3 to satisfy this, but they have the same voltage. So now, if you want to do this one, what different is what what different that one is voltage. That's why we say V1 plus V2. But this one is what current is different. So the total current here now will now be the current is equal to current of this one 1 plus current of this one 2 plus current of this one 3. Now what is now current? The total current here is equal to, from Ohm's law, V is equal to IR. So I will now be equal to V over R. That is from Ohm's law. So replace this I, place it with this one. So it will now be equal to V over R equal to, now for here, because we have the same voltage, so we now say V is equal to R1 for this R1 here, plus V is equal to R2 here, then plus what? V is equal to R3 here. So now we can then say equal to V over R equal to, then what is common here? We know V here, V here, V here, V common. So you can say V open bracket 1 over R1 plus 1 over R2 plus 1 over R3. So now in this case, so this V will cancel this V. So we now have 1 over R equal to 1 over R1 plus 1 over R2 plus 1 over R3. So this is the formula to let's call this one equation star, 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 star. So this is the formula for the. Now let me quickly short it now before we now move to the last question that we ask you here after this one. I will just draw the diagram. They can use mouth to say it. Let me draw the diagram. If you have something like this, they will say 2 resistors of so maybe 2 ohms. Let's say 2 ohms, 2 ohms, and 2 ohms, and 2 ohms. They will say are connected in what? 2 resistors of 2 ohms, 2 ohms each are connected with another 2 ohm resistor in parallel. That what is the what? The equivalent resistor. They can say connected, this one passing through a potential difference of, let's say, 5 volts. Let me just form the question like this. Then they now ask you to find the current as well. Now let me just say it like this. So first of all, to make this one, we just say, remember that R is equal to R1 plus R. So before you do that, find this one first. Find this. So we now say 1 over R, because this is the formula for in parallel, but this is in series. We say equal to what? 1 over R plus 1 over R. R1 and R2, which is 1 over R equal to what? 1 all over 2 for here, then plus 1 over 2 for here. The LCM is 2. 2 here, 3, we have 4 times 1, 1. 2 here, 1, 2 here. So we have what? 1, which means 2 over 2. Then we have 1 over R equal to 2 over 2. 2 here, 1, 2 here, 1, which is 1 over R equal to 1. So R is equal to 1 ohms. So which will now break this particular circle into 2 ohms connected to 2 ohms, then connected to 1 ohms. So this one has turned to 1 ohms now. So we now connect it to what? The PD of what? 5 volts. So now in this case now we can now do this one. We say R equal to R1, this is in series now, plus R2 plus R3. So we now say R is equal to 2 plus 2 plus 1, which is equal to 5 ohms. 5 ohms. Now we now go to Ohm's law. Ohm's law that says V is equal to IR to get the what? To get the current. So divide both sides by R. we now have V over R. So I will now be equal to, what is voltage? 5. What is the total resistor is 5. So which means 5 divided by 5, we have 1 ohms. So 1 ampere. So the current is 1 ampere. So that is what I can set here for you. Now let me now set this one that contains many things. Let me clean this one. I hope I'm done with this one. So if time permit me, we can move to wave. But or you write it. Wave is very, very long, but I don't think. But if I see that I still have the strength, let's solve this one together. Let's solve this one together. So follow me. I will be dictating it again. A battery of 3 cells in series each of EMF means electromotive force, 2 volts, and internal resistance 0.5 ohms. That is internal resistance of the battery. Then is connected to a 2 ohms resistor in series with a parallel combination of 2 3 ohms resistor. Now draw the circuit. Draw the circuit diagram and calculate the A. That is first step, the effective external resistance. Then B, the current in the circuit. Then C, the lost volts in the battery. Then D, the point in one of the 3 ohms resistor. Solution. Now, the first one, we are asked to draw the circuit diagram, which I've already explained how to draw the circuit diagram. So let's interpret it together. A battery of 3 cells, which means it contains 3 cells in series, each of EMF of 2 volts. That is, each of it 224, which is called 3 times 2, making 6 volts. So internal resistance of 0.5, which means the total internal resistance will be 1.5 because it's 3. Then it's connected in a 2 ohm resistor in series. 2 ohm resistor in series like this. Then with a parallel combination, we have now parallel of 2 3 ohms. That is 2 3 ohms, which is 3 plus 3, making 6 resistor. Draw the circuit diagram. The first thing you do is you draw it like this. This is the symbol of resistor. That is why you must know all the formula. This is symbol. Now you now connect it to what? To 3. 2 of 3. So it will now share like this. You can see. So for this one, there is mark for it. So how do you now make 3? This is 1. This is a cell of 1. This is another one. This is making 2 cells. Then this is another one. That's why you have to know the symbol. So you can see 1, 2, 3. So you have drawn it. So you can then say R is equal to 3 bracket 0.5. Put it like that. R mean internal resistance. Why the big will be the what? The external resistance. So now mark it. This one for this is 2 ohms, 2 ohm resistor. Then this is now 3 ohm and 3 ohm resistor. So if you can do it like that, you have solved one part. Then they now say the effective external resistance. The effective external resistance. So how do you now do it? Is this. Then they now say the loss of what? Voltage. So now it will now be equal to add this and this together. Will give you. They are not talking about what? They are not talking about internal resistance. They say external only. External, the one you connect externally. But this one is the internal resistance that the battery is made of. So now, how do we now do this one? First, solve this one. Solve this one too. So this one will now be equal to, using the formula. This is formula of parallel. In parallel. Yes, 1 over R equal to 1 over R1 for this number. Then plus 1 over R2, which will give us 1 over R. Will give us 1 over 3 plus 1 over 3, which is all over 3. The SM is 3. 3 in 3, 1. Then times 1, 1. 3 in 3, 1. Times 1, 1. Which will give us 2 over 3. So we now have 1 over R cross multiply 2 over 3. This one multiplied by this one multiplied. We have 2R equal to 3. So our R will give us 3 over 2, which will give us 1.5 ohms. So this is 1.5 because 3 in this, yes, is 1.5 ohms. So now, as a result of that, the circle here can also be formed like this now. So which means this is 2 ohms and this is 1.5 ohms. Now, in this case now, the total will now be in series now. R will now be equal to R1 plus R2, which is equal to 2 plus 1.5 to give us 3.5 ohms. So number A now, we have solved A, which is R is equal to 3.5 ohms is the answer. Now, this one solves everything about what we are talking. So they now say the current in the circuit. The current in the circle. What is the current in the circle? Now, they now say, what is the current in the circle now? So what you have to do is this. We need to find the what? The current by saying that V is equal to I. And because we have what is known as what? What is known as internal resistance. For find the internal resistance. So we now say I. We say I equal to E over R plus small r. To find the current in the circle. Because this one is also be blocking it. So we now say that is B. Now we are solving B. I have given you this equation before, where I say V over R equal to E over R plus R. Check this one. So this is which is also I. So we now say the UMF is equal to 6. The total UMF 2 plus 2 plus 2 plus 2 will give you 6. So 6 is here. So then the resistance here, that is A, will be what? 3.5 plus. Then the R here is equal to, in 3 places, 3 times will be 1.5. So this is 1.5. So we have I equal to 6 all over, then 4, 5. Because 3 plus 1, 4, then half and half in 5. So we have 6 divided by 5 to give us 1.2. So meaning that the current 1.2 ampere. Our current is equal to 1.2 ampere. So we have solved this one, we have studied. So they now say lost voltage in the battery. Lost voltage in battery. I need to, in what I was deriving, I need to derive something. So let me clean all these things. So I'm trying to manage time. So sorry for that. So let me write what I just solved here. We say our current is equal to 1.2 ampere. Then our R is equal to 3.5 volts. So I think that is where we. Now in this case, we are now to find the loss of voltage. You know, I said E equal to I R plus small r. Now, let's now try to get loss of voltage. So we now say E, which is EMF, equal to this time this we have IR plus I is. Let's start it. Now, we are trying to derive equation to give us loss of voltage. So now we can say V from Ohm's law is equal to IR. It's IR. Meaning that this one will turn to V. E is equal to V plus IR. So make IR the subject of formula. So IR will give us E minus V. All this one equation lambda. Let's call this one equation lambda. So this is loss of voltage IR equal to. Now, what is this one? C minus V. How do we get V? It's our questionable. It's questionable. Now, how do we now get V here? Remember that V is equal to IR. That is IR. So V, what is I? I is current, which is equal to 1.2 times then, and that one will multiply by R. This is R. This is what we get for R. What we get for internal is different from internal resistance. So now we now say 3 times 3.5. So V is equal to. So we have 1.2 times 3.5 will be what? Will be 4.2 voltage. Now we have IR equal to 6 minus 4.2 voltage. So we have IR, which is the loss of voltage, is equal to then 6 minus this. So minus 6 will give us 1.8 volts. So this is the. Now, I told you why I was explaining that when you take this battery now, the potential difference, which is what is, this is what the potential difference is. This is the battery. Let me say this is battery now. But the potential difference read this one 1.5 after powering something. It must have lost voltage. Is that taken? So loss of voltage is equal to the EMF of the cell minus when you now use it to power something. So the difference is what this battery lost. So this is the loss of voltage 4. Meaning that we have solved this one as well. So the current in one of the 3 volt resistor. We want to find the current in 3 volt resistor. So now let's clean this place. Okay, let me clean this voltage. Now, if you look at this one critically, I said the current will divide here, and the current will be divided into 2. Now, I will give you, they want you to apply your brain. And what is the total current is coming here? According to what I put for you, 1.2 ampere. You can see it's coming here. And if this one is 5, this one is 3, you need to find, but they have the same thing. Meaning that the current here, they have the same. What do you think is the same when we divide this one into 2? The current here will now be equal to 1.2 divided by 2. It's obvious. They share into 2 because they have the same resistor. The ability to resist will be the same thing. So meaning that 1.2 divided by 2 will give you 0.6 ampere. So the current in this one of it will be 0.6. If it is 2 of this, addition of this will now equal to this. Which means this one will be 0.6, 0.6. 0.6 plus 0.6 will give you 1.2. But they say the current is one of this. So one of these will now be 0.6 and 0.6 to give you the total current that is coming here. This is 1.2. Now, let me end it here. So let me remind you, go back to the previous video. Yesterday we have sent the what? We've sent a projectile. Go back to it. Then this one we are still going to send this one. Just check it, download it. So if time you may, I'm not promising, you may see project, you may see a wave. I may teach wave if time permit us to take this particular one. So thank you. So remember, we are taking GSS 1 to GSS 3 online and physical. Then also remember that we are taking from SS1 to SS3, and we're also taking 100 to 200. For 500 level. And also remember, take care is also there. We are still going to shoot it, and mathematics is also there, and other subjects. Thank you. Remain blessed.